Okay, so you guys, I'm not going to be with you in class today, but I did want to go through a couple of things from your Unit 2 Module 4 Student Notes Guide. The first thing that I wanted to talk to you about was this table that was here in the beginning of the notes. I wanted to let you know about these prefixes. We can pair any one of these prefixes with any one of our units of measurement. So for example, I can put the prefix mega with the unit gram, or I can put it with the liter, or I can put it with the meter. Any one of these prefixes that you see right here in this table can be paired with any unit of measurement. So I'm just going to write that. Pair with any unit of measurement. It doesn't matter whether that unit of measurement is an SI base unit or whether it is an English unit, but you can put that prefix with any unit of measurement. You guys should have already filled in these symbols right down here after going through the PowerPoint for Unit 2 Module 4. Okay, so that part should be already done. One thing that I specifically wanted to mention about this table is that there are 4 prefixes in this table that you will be expected to memorize. You do need to memorize the prefix kilo right here, deci right here, centi right here, and milli right there. Okay, those 4 prefixes are prefixes that may come up on the Chemistry SOL, and they do expect you on that SOL to know what that prefix does to a unit. So for example, if I put the prefix kilo in front of meter, that it automatically means that I've got 1,000 meters inside of a kilometer. Okay, so those 4 prefixes in the middle are the ones that are the most important that you need to memorize. Okay, any other prefixes, I will always provide the meanings of those prefixes for you. The last thing I want to mention about this table is that this particular table does not contain all of the prefixes that can be paired with a unit of measurement. This is only 6 different prefixes that can be used, so this is not an exclusive table. There are other prefixes such as nano and giga, those types of things, but we don't see those come up a lot in chemistry, and so I simply did not put them here in the table. But just know that they exist, okay? Now, what I'm going to do is I'm going to scroll down in the notes, right down here, okay? And I wanted to point to this particular section, in the notes right here, okay? I already told you that the prefix can be paired with any unit of measurement. And regardless of what unit of measurement it gets paired with, that prefix always carries the same meaning. So for example, in this first line right here, I have paired the prefix kilo with 3 different units of measurement: the meter, the liter, and the gram. But notice that every single time it has the same meaning. So a kilometer is equal to 1,000 meters, or a kiloliter is equal to 1,000 liters, or a kilogram is equal to 1,000 grams. So notice that the number that it represented, 1,000, never changed regardless of the unit changing. Okay? All right, next I wanted to scroll down and talk about how we can take any one of these equivalent statements, and these things that are written right here are called equivalence statements. Okay, I'm going to try to write that out if my pen will let me. Okay, there we go. Those are called equivalence statements. When you set 2 things, 2 numerical quantities, equal to each other, those are called equivalent statements. Well, any equivalent statement can be written in the form of a fraction. right here. We talked about that. It can be written in the form of a fraction, and what you should have found out that when you put an equivalent statement in the form of a fraction, that it then becomes called a conversion factor. So that's something that you guys should already have filled in based on going through the Unit 2, Module 4 PowerPoint. Okay? Well, let's say, for example, that I were looking at the equivalent statement 1 kilometer is equal to 1,000 meters. Well, I can take that equivalent statement right there and write it in the form of two different conversion factors. One of those conversion factors puts the 1 kilometer on the top and the 1,000 meters on the bottom. And the other conversion factor that I can make from that is I could write the 1,000 meters on the top and the 1 kilometer on the bottom. So again, now that I've taken that equivalent statement right here and put it in the form of a fraction here and here, those fractions are called the conversion factors. Okay? Any equivalent statement can produce two different conversion factors, all depending on what goes in the numerator and what goes in the denominator. Okay? So that's taking equivalent statements and writing them in the form of a conversion factor. Okay? Now, what we're going to do is we're going to try to look at some of these practice problems and see how we can use equivalent statements and conversion factors to perform a given conversion. Okay? So, what I'm going to do is I'm going to scroll down and we're going to look at these practice problems. Okay? In these practice problems, I actually solved B number 1 and B number 2, I believe it was, in your notes. I may have only done B number 1. I don't remember, to be honest. But anyways, there were a series of practice problems here. So let's say that we look at number 4, because I'm pretty sure that that's one that I did not actually perform for you in the notes. All right? I'm trying to convert 51.0 grams into decigrams. The little d in front of the G stands for the prefix deci. So I'm going to start by figuring out what is the conversion factor, or actually the equivalent statement that shows me what the relationship is between the gram and the decigram. So that equivalent statement is 10 decigrams equals a gram. Deci means 1/10, so it takes 10 little decigrams to fill up a gram. Okay? Well, I can put that equivalent statement in the form of two different conversion factors. I could write this 10 decigrams over a gram, or I could write 1 gram over 10 decigrams. Okay, but my job as the student is to try to figure out which one of these conversion factors, and I'm going to label them conversion factor A and conversion factor B. I have to figure out which conversion factor is the right one to use to solve the problem. So here's the way that we set it up. If I start with 51 grams, I'm going to set up what are known as the train tracks, which is just drawing, a large horizontal line and then a small vertical line, so that I put right here the quantity that I was given, which was 51.0 grams. And now here in the second part of the train tracks, I'm going to put one of these two conversion factors, either conversion factor A or conversion factor B. And only one of them is the right conversion factor to use to solve this particular problem. In this case, I would want to use conversion factor A and orient it such that 10 decigrams goes on the top and the 1 gram goes on the bottom. The reason that I chose to use conversion factor A is because by putting the 1 gram on the bottom, this unit, the gram, cancels out, because a gram over a gram cancels out. Okay? So now, to solve this problem, all I have to do is take the quantities that are on the numerator and multiply them, and then divide by any quantity that's in the denominator. So this would be the same as saying 51.0 times 10 divided by 1. So my answer, when I take 51.0 multiplied by 10, multiplying by 10 is the same as moving my decimal one place to the right. And so what happens here is this becomes 510 decigrams, like that. But, you guys, there's an important rule for significant figures. And that rule is however many significant figures that I started with right over here at the beginning of my problem, that's how many significant figures I need to finish with at the end of my problem. So 51.0 has 3 significant figures. So when I finish, my answer needs to also have 3 significant figures. Well, right now, as written, 510 only has 2 significant figures because it obeys the Atlantic to Pacific rule, going left to right. So I can't start on 0. My 1 and my 5 are significant as I go right to left, okay? So that 0 is not significant, but I need to make it significant. So the way that I can do that is by simply putting a decimal at the end. All right, got to make sure that, whoops, my screen just disappeared. Okay, sorry about that. But anyways, just by simply putting a decimal at the end of that 510, so like this, 510 decimal, and then decigrams. Can you guys see that decimal right there? Now that 0 is significant because now it becomes a Pacific to Atlantic rule, and I've got 1, 2, 3 significant figures. So for number 4, right over here, the final answer is 510 decigrams, like that, okay? So that's how we're doing problems such as those listed right here in the practice, okay? Problems down here under Part D are going to be very similar, except for they are going to be 2-step problems instead of 1-step problems. So for example, if I were to look at number 2 right here, I would do 12.01 milliliters. I do need to convert through the base unit. There are 1,000 milliliters in 1 liter. So I would orient that equivalent statement into the form of a conversion factor and put the 1,000 milliliters on the bottom and 1 liter on the top. I chose this particular orientation so that the unit of milliliters would be able to cross out. Now I need to convert liters to centiliters, and there are 100 centiliters in a liter, just like there are 100 centimeters in a meter. Centi means 100 of something. So over here, I'm going to put my 1 liter on the bottom, and I'm going to put my 100 on the top. This way, the liter crosses out. So I'm going to do 12.01 times 100, and then I'm going to divide by 1,000. Okay? So the other thing you can do here, if you know a little bit about math, is cross out zeros. Up here, these 2 zeros cross out with 2 zeros down here. So it's the same thing effectively as going 12.01 divided by 10. Which means move the decimal one place to the left. So my final answer for this particular problem is going to be let me get my pen back here. My final answer is going to be 1.201 centiliters, like that. Okay? So the only thing different here in Part D is that they are going to be 2-step conversion problems instead of just 1-step conversion problems like what we saw at the top. Okay? That's it. Thank you for listening. And now you need to go on and listen to the videos that describe the practice problems in Dimensional Analysis Worksheet number 1.